Hello everyone. So in this session let me continue few more theorems in complex analysis, and the next theorem is Cauchy's integral formula. So you have to remember statement also. Statement is if f of z is analytical, so I have already told you the definition of analytical, within and on a simple closed curve C in the complex plane C, and A is any point within a complex plane C, then we have to prove that f of A is equal to 1 by 2 pi into line integral or a closed curve C f of z by z minus A into dz. And further we are going to solve problems by using the same theorem. Now coming to the proof. So let me consider, as per the given statement, let me consider a complex plane C. Fine. And I have constructed a circle C1 with center at A, and let E epsilon be the radius of the circle. Now I have already told you equation of circle in complex form is modulus of z minus A is equal to R, where R is radius, but in the constructed circle radius is epsilon. So instead of R, let me take it as epsilon, so that you will get z minus A is equal to epsilon. Magnitude of z minus A is equal to epsilon into e power of I theta. I'll write it in exponential form. Now let me simplify this. E power of I theta, I can write z as, I'll shift A, so that you will get A into epsilon e power of I theta. Fine. When you differentiate this, you will get dz. Further I need these values, so that is why I am simplifying all this. So dz will be, here A is considered as constant. Fine. So A will be 0. Differentiation of A is 0. Again, when you differentiate this with respect to theta, you will get epsilon I into e power of I theta into d theta. Clear? Now let me consider integral of closed curve f of z into z minus A dz. I am going to consider this value. Fine. Now let me substitute the values that what I have constructed. Since I have constructed a circle C1, so I am going to replace C with C1 closed curve f of z divided by z minus A into dz. Fine. So I can write this as f of z minus A dz can be written as integral over, since I have constructed C1 as circle and the limits varies from 0 to 2 pi. Why? Because it is from 0 to 360, right? So f into, let me replace z by A plus, just now I have written here, A plus epsilon into e power of I theta divided by z minus A I need. So z minus A is given by epsilon into e power of I theta into dz is epsilon e power of I theta d theta. So let me substitute epsilon I e power of I theta d theta. Clear? So in the notes all these steps are not mentioned, so if you want you can copy from this video. So e power of I theta, epsilon and epsilon get cancelled. So what you left with, I can take I outside, so you left with 0 to 2 pi f of A plus epsilon into e power of I theta into d theta. Now since epsilon is an arbitrary and it is very small, so I can neglect this epsilon. By neglecting it, I can write 0 to 2 pi f of A into d theta. Since we are integrating with respect to theta, f of A will become constant, so I can take it outside. Let me write LHS part. What we have, f of z by closed integral C1 z minus A dz. I and f of A I can take outside, so I will get 0 to 2 pi d theta. Now integration of d theta is theta, limits varies from 0 to 2 pi. Now let me substitute the limits. So I'll get I into f of A, upper limit 2 pi minus lower limit. So you will get 2 pi I into f of A. Let me write here C1 f of z divided by z minus A dz. Now let me shift the value of f of A, so that you will get, I'll keep f of A one side and I'm going to shift this. So I can shift this value, so I can write this as 1 by 2 pi I into integral over C1 f of z divided by z minus A into dz is equal to f of A. And we can note that this is what we have to prove is, see here, f of A is equal to 1 by 2 pi I into closed integral over C f of z into z minus A dz. Fine. So that is what I have obtained. Anyhow, C is any general curve, so I can write this as C. Instead of C1, I can write C only. Fine. So this is what we required to prove is. Hence the proof. Hope it is clear. But all these simplification is not given in the notes. Please copy to the notes. So here is the next theorem. It is called as generalized Cauchy's integral formula. So one more name for that, Cauchy's integral formula for derivatives, and it is important. It has asked in the year 2018. So you have to remember the statement as well. If f of z is analytical function and on a simple closed curve C, and if a is any point within C, then we have to prove that f power of n, that is f differentiated n times with respect to a, is given by n factorial divided by 2 pi into integral over closed curve C f of z divided by z minus a power of n plus 1 into dz. It is just a generalized case of the previous theorem that I have proved now. Now let me coming to the proof. So by Cauchy's integral formula, just now I have proved, right? Cauchy's integral formula, let me make use of the same. So this is what I have proved, right? So I am going to make use of Cauchy's integral formula. Let me write Cauchy's integral formula here. So from Cauchy's integral formula, what we have, let me write the statement. F of a is equal to 1 divided by 2 pi I closed integral over C f of z divided by z minus a into dz. So this is the statement of Cauchy's integral formula is. Now let me take this as equation 1. Hope so you remember that if you want to differentiate under the whatever the term we have under the integral sign, we have to apply Leibniz rule, right? So let me apply, why? Because we have differentiation here and moreover integral sign we have. So let me apply Leibniz rule of differentiation under integral sign. So if you apply that, I can write this as, since we are applying with respect to a, I can write that as dou by dou a of f of a is equal to 1 by 2 pi I is constant. Let me write as it is, integral over C. Now let me differentiate dou by dou a of, since f of z is independent of a, I can take this outside. So I can write this as 1 by z minus a, f of z outside, f of z into dz. Fine. Now let me write one more step. I can write this as f dash of a. Dou by dou a of f of a is none other than f dash of a. F dash of a is equal to 1 by 2 pi I closed integral C. Now we know that differentiation of 1 by x is minus 1 by x square. So it is of the form 1 by x. I can write this as minus 1 divided by z minus a whole square. Further differentiation of a is minus 1. Right, so like differentiation of x with minus x with respect to x is minus 1, right? So likewise I have differentiated this and f of z into dz as it is. Now minus into minus will become plus, so what you get, 1 by 2 pi I integral over closed curve C minus into minus will become plus. I can write like this. Clear? So instead of 1 I can write here 1 factorial. So I can write this as 1 factorial into f of z dz, one and the same. Fine. Now let me apply one more time, that is apply Leibniz rule of differentiation under integration. I am going to apply once again, so that f dash of a will become, for the second derivative I can represent the same as f double dash, right? So f double dash of a is equal to, let me keep this as it is, 1 divided by 2 pi I integral over C, f of z into dz will become constant. Now we are applying with respect to a, 1 divided by z minus a whole square. Fine. So in the notes all these steps are skipped. Please write down all the steps so that you can understand well. So z minus a whole square, when you differentiate this, you can note that it is of the form 1 by x square, right? Or else I can write this as, see here, z minus a whole power of minus 2. When you differentiate this, you will get n into x power of n minus 1, in the sense minus 3 you will get n minus 1, right? So minus 1 minus 2 is minus 3 into minus 1. This minus into minus will become plus. So 2 into z minus a power of minus 3. I can write the same as 2 divided by z minus a whole cube. Fine. So I'll just write here 2 pi I into, after differentiation what you're going to get, 2 into z minus a whole cube f of z into dz. So instead of cancelling, I can write this as 2 factorial divided by 2 pi I into integral over f of z minus a whole cube into dz. Fine. So for the first time I have obtained this, for the second time I have obtained this. So if you generalize this concept and applying it for the n times, so 3 I can write this as 2 plus 1 and the same. right? So if you apply 2 times differentiation, you will get 2 here, again 2 plus 1 here. So n I can write, so let me apply n times. So I can write this as f power of n of a, as in place of 2 I can write this as n factorial divided by 2 pi I integral over c f of z divided by z minus a. In place of 2 I can write n here. Why? Because in place of 2 I have n. So n plus 1 into dz, and this is what we require to prove is. Hence the proof. Hope it is clear. Now let me solve a few problems on the same concept. So here is the problem. So before solving the problem, I'll just tell you the procedure, that first we have to find the point z is equal to a. First step. Fine. Second step is we have to find whether this point z lies inside the circle or outside the circle. We have to find. It is just for your reference. Anyhow, I'll explain in detail. Now, if the point, third step is if the point z is equal to a lies inside the circle, then we have to apply Cauchy's integral formula. Fine. And fourth step is if it lies outside the circle, then I can apply the formula Cauchy's integral theorem, that is f of z into dz is equal to 0. Now let me solve one problem so that you will get an idea. Now here I have a problem. Evaluate f of z divided by z minus 1 into dz, where circle equation is given by mod z is equal to 0.5. Now compare it with the standard equation, z minus a is equal to r. Anyhow, e power of I theta, you leave it. So radius is 0.5. Now let me write here, given c is equal to mod z, which is 0.5. Here a is equal to 1. Fine. And moreover, a is equal to 1 lies clearly outside the circle, right? Outside the circle. Here you have to compare with this. A value can be obtained from this expression. In the sense, it is z minus a form. So a is of the form 1. In place of a, I have 1. Whereas in the circle, a value is 0. But radius is 0.5. So in the inside the integral, that is I can say integrand, a value is 1. So this point lies clearly outside the circle. Why? Because I will show you here. See here, radius of a circle is 0.5. Right? So right from center to 0.5, circle will be something like this. So radius is 0.5. 1 lies here. So clearly 1 is outside of this circle. So I can write a is equal to 1 lies outside the circle. Fine. Now as per the theorem, I can directly apply Cauchy's integral theorem. What it says? Integral over f of z dz. Right? Where f of z I have to take as 1 divided by, or I can write f of z divided by z minus 1. So this entire integrand value I can consider as f of z. Now by the theorem, this value is 0. Therefore the given problem value is f of z divided by z minus 1 is equal to 0. I'll just repeat once again. You have to compare z minus a value and you have to take this a value as z, that is z is equal to a. And now we have to check whether this point lies inside or outside of the given circle, and then apply as per the rule. So if it lies outside the circle, we can apply Cauchy's theorem. If it lies inside, we can apply Cauchy's integral formula. Now let me explain one more problem so that you will understand well. Suppose if they ask you like evaluate integral over c e power of z divided by z into z minus 1 dz, where C is a circle given by mod z is equal to 0.5. We have two methods to solve the given problem. I'll do it in both the methods. Now, first we have to consider the integrand value, that is leaving a numerator. Let me consider the denominator. Why? Because it is product of two functions, right? So we cannot predict the value of a here. So let me consider the value 1 divided by z into z minus 1. As you already familiar, how can we split this? By using partial fraction. So let me write this as a divided by z plus b divided by z minus 1. So let me solve this. 1 is equal to a into z minus 1 plus b into z. So let me put the value of z as 0 so that you will get value of b. So when z is equal to 0, this value goes up. So you will get a into 0 minus 1. So the value of a is minus 1. Similarly, put z is equal to 1 so that the value of a becomes 0. So you will get b value 1. Hope so partial fraction is known for you. Now a value and b value is obtained. Let me substitute here. So you will get 1 divided by z into z minus 1 is equal to a is minus 1 divided by z plus b is 1 divided by z minus 1. Fine. Now let me substitute here. So this given problem, closed curve e power of z divided by z into z minus 1 dz can be written as, I am going to split this as minus 1 divided by, e power of z divided by z into dz plus integral over c e power of z divided by z minus 1 into z dz. I have splitted this by using partial fraction. You cannot directly split this. Why? Because you can note that here we have a change of sign. So I can write the above step as e power of z divided by z minus 1 dz minus e power of z divided by z into dz over closed curve C. So given problem I have split it into two terms. Fine. Now let me take this term as I1 and let me take this as I2. Now we have separated two terms, so we can solve individually. So let me solve for I1. Let me consider I1. I1 is given by integral over C e power of z divided by z minus 1 into dz. Fine. Now consider a given circle equation. What is the circle equation given? Mod z is equal to 0.5. Now here z minus a form is given by z minus 1. Fine. Now comparing with this, a value is 1. Clearly a is equal to 1 lies outside the circle. Outside the circle, mod z is equal to 0.5, right? Why? Because 0.5 is somewhere here. So 0.5 is somewhere here. But a is equal to 1 is here. So 0.5 covers the circle. So it lies outside the circle. So as per the Cauchy's theorem, when we have mod z is equal to, when we have a point lies outside, we can directly apply Cauchy's theorem. So Cauchy's theorem says that f of z into dz is equal to 0. But we have to consider f of z as given function. So let me take f of z is equal to e power of z divided by z minus 1. So by Cauchy's integral formula we can directly write that f of z into dz value is 0. So we have obtained I1 value as 0. Clear? By Cauchy's theorem. Why? Because it lies outside the circle. Now let me solve for integral I2. I have solved for I1. So I1 value I have obtained it as 0. Now similarly let me solve I2. Let me consider I2 here. So I2 is given by what is I2? E power of z divided by z into dz over c. Fine. Now equation of circle given is mod z is equal to 0.5. Now we can clearly say that compare with the z minus a. Since it is given is z, so value of a is 0, right? Why? Because we don't have a here. Hope so it is clear for you. So you have to compare z minus a in the denominator value. Here a we don't have, so a is equal to 0. Clearly a is equal to 0 lies inside the circle, right? So circle is of radius 0.5. So circle covers something like this. So a will be somewhere here, 0, right? So 0.0 lies, let me write here, a is equal to 0 lies inside the circle of radius mod z is equal to 0.5. Radius 0.5 I can write. Inside the circle mod z is equal to 0.5. You can, if you want, you can write inside the circle of radius 0.5, one and the same. Now we have to apply, this is very important, you have to write this. We have to apply Cauchy's integral formula. I'll give the procedure anyhow, please understand. If it lies outside, we have to apply Cauchy's theorem, thereby the value goes to 0. Fine, if it lies outside. If it lies inside, you have to apply Cauchy's integral formula. So let me write the integral formula. Just now in the same session I have explained. Please go through that. So let me write the statement. Cauchy's integral formula says that f of a is equal to 1 by 2 pi I into integral over c f of z divided by z minus a into dz. Or else, since I want the value of this expression, I can rewrite this as f of z divided by z minus a into dz as, let me cross multiply, 2 pi I into f of a. Hope so it is clear, right? Now consider the integral value, integrand value, that is I2 value what we have, integral over c e power of z divided by z into dz. Fine, in place of f of z by z minus a, that is what I have, right? See here, f of z by z minus a, I have e power of z. F of z is e power of z, z minus a is z. Fine, it is 2 pi I into f of a value is 0. Clear? F of z value is e power of z. F of z value, compare it with the standard form, f of z is e power of z. I have considered the integrand, I am comparing it with Cauchy's integral formula. So f of z is e power of z, f of a value is 0. Why? Because we don't have any value at place of a. So I have to find f of 0 value. E power of 0 is 1. So this value is 1. So I'll get 2 pi I into 1. So the value of integral over c e power of z by dz is equal to 2 pi I. So the value of I2 I have obtained it as 2 pi I, whereas the value of I1 is 0. Now let me consider equation 1. Let me take this as equation 1. I am going to substitute the value of I1 and I2. So I can write that as, see here, e power of z integral over c divided by z into z minus 1 dz is equal to I1 value is 0. Substitute. Plus I2 is 2 pi I. So the value of e power of z divided by z into z minus 1 into dz is 2 pi I. I'm sorry, we have minus here, right? So I have to put minus here. I'm sorry, I forgot here. See, I have minus here, so you have to put minus here also. I1 value is 0. 0 minus I2 value is 2 pi I. So you will get minus 2 pi I here. Hope so it is clear. Fine. You just go through the problem and you have to understand that if a point lies outside the circle, you have to apply Cauchy's theorem. If it lies inside, you have to apply Cauchy's integral formula. Anyhow, I will send you the procedure. Before that, at the beginning of the problem, if you have product of two terms, you have to apply partial fraction to resolve it. Hope so it is clear. Now let me solve one more problem. We have second method, right? So I have explained one method only. So you can solve the same problem by using second method so that you will get the same answer. Let me solve by using the second method. So given problem, I am going to solve by using the second method. So let me write the problem here. What is the problem we have? Integral over c e power of z divided by z into z minus 1 dz. Fine. Now second method it is. Second method. Both the methods is easy. Fine. Whatever the method you want, you can do. But first method is having more steps. So if you do that method, it will be easy, and moreover they'll give mark without cutting any mark. Hope so. But anyhow, second method is also easy. You solve by looking at the mark. It depends on valuator. Fine. So second method. Now you can compare the given function without splitting. In the first value, z is equal to 0. Z is equal to a, right? Standard form. So I can write in the first term z is equal to 0. In the second value, a value is z is equal to 1. Fine. Next step, you have to write whether the point lies inside or outside. Now you can note that the point z is equal to 0 lies inside. Given circle equation is c is equal to mod z is equal to 0.5. Right? So given circle is 0.5. I have z is equal to 0 lies inside this given circle, right? Inside given circle. Why? Because 0.5 lies here, 0 lies here. So it is definitely inside the given circle. And moreover, the point z is equal to 1 lies outside given circle. Clear? Now, so in the sense both the methods are same, but what I am trying to do is instead of writing all the steps, I am going to write it in one step only. In the sense when the point lies inside the circle, so you can directly write it as 0. When it lies outside the circle, you can apply Cauchy's theorem. So instead of doing all these simplification, you can directly write it in one method. My opinion is please don't go for second method. So it is better to follow only one method. So you try to do in this method only. Further, if you have any doubt, I'll be there to help you. So this method is very convenient. Anyhow, if you want, I'll do that only. See here, since z is equal to 0 lies inside and z is equal to 1 lies outside the circle. Since if it lies outside the circle, I have already told you, we have to apply integral theorem. So when z is equal to 1, this term will not be there. In the sense, by integral theorem, that value goes to 0. That is what I have done in the first case also. So instead of writing all those things, I can write the first term as 0. So after splitting the term, you have to consider this step again. In the sense, I can write this as c e power of z divided by z minus 1 into dz minus e power of z divided by z into dz. Fine. So this value will not be there. Why? Because z is equal to 1 lies outside the circle. By integral theorem it goes to 0. Now z is equal to 0 will be inside the circle. Now we have to apply the theorem once again. So again you will get after simplification you have to do all the steps, right? What is the theorem says? So this one. Again same thing you have to do and you have to substitute one and the same. But instead of writing this, hope so it will be very convenient and easy to do in this method. Fine. Now let me solve one more problem in the next session so that you will understand very well. But before that, please learn partial fraction properly. Thank you. Continue in the next session.